Okay, today we're starting a new unit in math. We did our assessment on dividing decimals, so now we're moving on to coordinate planes. At the end of this, you're going to be able to use a pair of perpendicular lines called axes to define a coordinate system, understand the meaning of x-axis, y-axis, and apply that understanding to locate an ordered pair on a coordinate plane. Now you're looking at me like, what does that mean, right? Okay, put your eyes up here. That's why this is up here. Today, we're going to learn about the coordinate plane. This is called a coordinate plane because a plane in geometry is a figure that, it's a four-sided figure, but it's flat. It has no depth. So a coordinate plane is kind of like a graph that we can graph things on. Today, we're going to just be focusing on one section of this coordinate plane to start off with our introduction lesson. Each section of this coordinate plane is called a quadrant. You have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Depending on your ordered pair, depends on the location and which quadrant it'll be located in. Today, like I said, we're focusing on one quadrant, just quadrant 1. But I wanted to draw this up here so you can see the whole coordinate plane as itself. Yes, Brandon?
Why does it go 1, 2, 3, 4 that way?
Why is it numbered that way?
Yeah.
We'll get into that more in our next lessons when we talk about all of them, but quadrant 1 has all positive locations. It has all positive locations. Okay, so quadrant 1 has all positive locations, and that's what we're going to be talking about. Right now, you're going to put your eyes on the board. You're going to watch a brain pop video on coordinate planes. Luke, when I tell you in just a second, do you hit the lights for us? No, you're fine. Okay, Luke. What are they playing?
Chess.
Okay, they're playing chess. We'll talk about it in a second.
How does a robot keep beating me? Dear Tim and Moby, how do you convert data from a table to a graph? Thanks, Taylor. Well, to convert data to a graph from a table of values like this one, you need to know about coordinate planes. A plane is a flat surface with length and width, but no depth. In other words, it has 2 dimensions instead of 3. And it has no edges, sort of like a piece of paper that goes on forever. Oh, well, planes aren't real. They're imaginary models of space. A coordinate plane is a plane overlaid with 2 perpendicular number lines. Those lines help you find any point on the plane. It's also known as a Cartesian plane, after René Descartes, the guy who developed the idea way back in 1637. Basically, he drew 2 perpendicular lines in the middle of a plane and called the place where the lines intersect the origin. One line represents the horizontal...
What's located at location 0, 0, Austin?
Origin.
The origin.
distance from the origin. We call that the x-axis. The other line represents vertical distance from the origin. That's called the y-axis. These lines help us find our way around the plane. Well, everything starts from the origin. The coordinates, or the address of the origin, are 0, 0. That means to find the origin, you have to move 0 units horizontally and 0 units vertically. The set of numbers that describes a point is called an ordered pair because the order of the numbers matters. For instance, 2, 3 is different from 3, 2. The first number tells you the address of a point on the x-axis, while the second number tells you the address of a point on the y-axis. So, to find the point described by the ordered pair 2, 3, you'd start by looking at the first number, the x-coordinate. It tells you to go 2 units to the right. Next, you look at the second number, the y-coordinate, which tells you to go 3 units up. Now I'm at the point 2, 3. But if you were finding the point described by the ordered pair 3, 2, you start out by going 3 units to the right and then 2 units up. We're in totally different places.
No, totally different places.
Each section of the coordinate plane is called a quadrant, because there are 4 of them. You can always predict what quadrant a point will fall in by looking at the positive and negative numbers. Quadrant 1 has all the points with a positive x-coordinate and a positive y-coordinate, like 2, 3. Quadrant 2 has all the points with a negative x-coordinate and a positive y-coordinate, like negative 2, 3. Quadrant 3 has all the points with a negative x-coordinate and a negative y-coordinate, like negative 2, negative 3. And Quadrant 4, Quadrant 4 has all the points with a positive x-coordinate and a negative y-coordinate, like 2, negative 3. You can remember that x comes first because, well, x comes before y in the alphabet. Nope, this doesn't help me win chess at all. Play again?
Okay, so when they went to plot the location of 2, 3 and 3, 2, did they end up in the same place, Bradley?
No.
No, because first you have to plot the x-axis, then you plot the y-axis. One way that I found to remember this is if you were going to take off, you would obviously run before you went to jump, right? You're going to jump higher if you get a running start, right? So you need to run before you could jump, right? So the way they gave you on the video was y, or x, not y. X comes before y in the alphabet, right? So that's one way to remember it. You're going to go the x-axis first, then the y-axis. But I thought it was pretty neat to say, to remember to run before you jump. So we're going to do the x before the y. So what does it look like? This will be hanging in the room. The vertical axis are called the what, Nathaniel? The y-axis. They run up and down. The horizontal lines are called what, Emily?
The x-axis.
The x-axis. And then, when we have an ordered pair, an ordered pair is an exact location. If we have an ordered pair, we're going to be able to pick an exact location. Hold it to the end, Brandon. An exact location for this coordinate plane. Depending on what the ordered pair is, we always start from this point right here, that's 0, 0, and it's called our origin. So the ordered pair is determined from its distance from this origin because you start at 0, 0. So if we have the ordered pair 2, 2, that means we have to do which axis first, Kirsten?
We have to the x-axis.
The x-axis first. So this first number, Tyler, tells me which axis?
X.
The x-axis. So that means I start at the origin, I start at 0, 0, and I'm going on my x-axis 2. 1, 2. This number is my y-axis. I'm going what, Ethan?
2.
So where I'm at on my x-axis, now I have to jump 2. 1, 2. This would be my ordered pair 2, 2. Am I always going to jump up? Why, Brittany? I have different quadrants. Each quadrant has different locations, and depending on my coordinate, right, each of these are called my coordinates. Depending on them determines which quadrant I'm going to end up in. We're going to say that we run before we jump, just to remember our x-axis and our y-axis. But we may not, our jump may not always be upward. Our jump could be downward if our y-axis are a negative number. But today, guess what? Our jump is always going to be upward, because we're just going to be looking at this quadrant 1 today. So looking at this coordinate plane that we have on the board, my origin is located at what, Kendall? 0, 0, 0. My origin is at 0, 0. That's its exact location. So we're learning this in math, but why is it important? Who cares, right? I mean, it's coordinate planes. It's kind of cool. We get to mark x and y axis and location. Why is it important? Why is it important, Brandon?
Because it helps you maybe, it helps you knowing like,
Why is it important, Nathan?
It helps you on maps because maps are in coordinates too.
Very good, Nathan. Air high five. Maps. And when I think of the kind of map that's set up with coordinates or exact locations, I think of an atlas. And I know today your vehicles probably have, or your parents probably have GPS. They have a TomTom in their vehicle. It's a mapping thing that tells you turn left in half a mile. So do you have to know how to read the atlas? Not if you have one of those, but is it good to know how to read an atlas?
yes, not really.
Because what if you didn't have one? Or what if your smartphone, you couldn't get any cellular data? Guess what? You may need to learn how to use an atlas. And an atlas is set up with exact location. It has coordinate planes. When Butch and I go on vacation, he always brings us road atlas. We have a TomTom and we have smartphones, but guess what? That handy dandy atlas will never let us down. So if you know exact locations, it's always on the map. What else is set up with exact locations? What else, Annika? What's this? Does the globe have exact locations, Annika?
No.
What are the two things how a globe is defined that is exact locations, Jesse?
The longitude and latitude.
The longitude and latitude. It has exact locations. If you are in social studies and looking at the atlas and somebody gives you the exact locations according to the longitude and latitude, guess what? It's set up like a coordinate plane.
What if you knew there was soccer fields?
You would know where that is so cool.
Yeah,
Then you could use a map to get there.
It wouldn't be on the map, maybe.
But the place where the soccer game would be.
The location with the exact location of where it's located. The park could be. As we go more into this unit, you're going to start having maybe some local maps or a city map, and you're going to have to tell me the exact locations of maybe the frog pond, the exact locations of the grocery store, the exact locations of the soccer field. Because using a coordinate plane, you can find exact locations. You can find exact locations on the globe. Think of everyday life. What is it in everyday life that children like that uses something like a coordinate plane? Think of the video. What were they doing? They were playing chess.
No one really plays chess.
What about checkers, Dylan says? It's set up kind of in a gridded. The game Battleship has exact locations.
I love that game.
If you've ever played Battleship, you have to sink their whole ship. You have to get hits. If their boat has 4 prongs in it, you have to get on the exact location of all 4 of those. Guess what? That's a coordinate plane. You're doing math when you play Battleship. That's why it's important. It's important that you know how to do this and know how to plot exact locations. You're going to look at the board. You're going to need your clickers. Hold on. Before we do this, before we do your clickers, let's plot a few points up here together. Somebody give me a number 1 through 6. Give me a number 1 through 6, Amelia. 5. Somebody else give me a number 1 through 6. Corey? 4. 5, 4 is our what, Bradley? What's it called? This is our what? Look at the anchor chart. 5, 4 is called our what? Look at 2, 2. What was it called? It was an exact location, but what's it called? Two is an exact location. What's this exact location called? What are they called? This is an ordered pair. 2, 2, right? It was right here. What's 5, 4 called, Bradley? An ordered pair. This ordered pair is going to give us an exact location on this coordinate plane. Alright, 5, 4. I have an ordered pair on my paper now. I'm not sure what to do with it. Kendall, what's the first thing I do with this ordered pair? Miss Brown says I have to use this ordered pair to plot an exact location on here, and I'm not sure what to do. What do I do first? How'd you know that? Kendall says I go over 5 because this number means my x-axis. Good job, Kendall. Okay, so I went over 5. Now I'm done. Why not, Kirsten?
Because you have to plot your, well, you have to finish, you have to do the line.
I have to do my y-axis. If I was to leave this, let's say that I didn't know what to do next. And on my paper, I left it here. I went over 5. There's my exact location. Why is this wrong? What is this exact location that I just marked, Brandon?
Or no, it's wrong because it's, you was telling you to plot 5, 4, you only plotted 5.
I only plotted 5. But you know what? What is it, Dylan? This would be 5, 0. Because I did go over 5 on my x-axis, didn't I? 1, 2, 3, 4, 5. But how much did I go up or down on my y-axis? 0. So is this an exact location on this coordinate plane?
No.
Yes. Thumbs up for yes, thumbs down for no. Is this an exact location? It is. Because sometimes you may move on the x-axis and not the y-axis. Guess what? Would this be an exact location on this coordinate plane?
Yes.
Let's see what it means. This means which axis?
Yes.
So I'm going how much?
0.
0. This is my y-axis, and I need to do what with it?
Go up 5.
Go up 5. Is this an exact location?
Yes.
Yes. I moved I moved from my origin. I did. I didn't.
Is that 0, 5?
Oh, I did it wrong. Thank you. I moved. If I move off of this origin, then guess what? It's considered an exact location on here. If I stay at 0, 0, I never left the origin. But if I move from that, either any which way, I've moved from my origin, so it's an exact location on this coordinate plane. Let's go back to this one. Okay, I went over 5. You said that I need to go up 4. That's what Kirsten told us. This is the exact location with the ordered pair of 5, 4. Yes,
It's kind of like using a compass. It's like north, south, east, west. You go west, 5.
and first, okay, if we think of it as a compass, like Jesse says, you're going to move in the directions of either
East
or
west.
first, and then you're going to either go,
South.
okay, let's put that on here. If we think of it as a compass, you need to move east or west first, then move. I like it, Jesse. North or south. Okay, now you're going to get your flickers in your hand. You have five questions. I think using a coordinate plane is interesting and makes math fun. True or false? I think using a coordinate plane is interesting and makes math fun. Is everybody going to like math all the time?
No.
No. Is it okay?
No. Yes, I guess.
Brian? Okay. Your next one. I feel confident in my ability to locate an ordered pair on a coordinate plane. I feel very confident in my ability to locate an ordered pair on a coordinate plane. I feel somewhat confident. I feel a little confident, or I don't feel confident at all. We're just halfway through this lesson, I know, so I'm just trying to see if you think you...
That's it.
You think you're okay with locating them, or you still need a little bit of time?
Why is it 25 on there? 23 on the last one.
The next one. That one was locating an ordered pair. This one is graphing. I feel confident in my ability to graph an ordered pair. So if Miss Brown was to give me this ordered pair, I feel confident that I could come over here and graph it correctly. I feel very confident. I feel somewhat confident. I feel a little confident.
Sometimes I get mixed up.
There's no right or wrong answer. I'm not looking for a right or wrong answer. I'm just listening to your answer.
That's all self-control.
Dang, all.
The origin of a coordinate plane is sometimes located at 0, 0, located in the first quadrant, always located at 0, 0, or located at points 5, 4. The origin. Keep them up because I'm still missing a couple. Go get it. Your last one. When located in ordered pair on a coordinate plane, I first go across on the x-axis, or I first go up on the y-axis. When locating an ordered pair, I first do what? A or B? Nathan, you have to turn it toward me. Thank you. A or B? When I'm locating an ordered pair on a coordinate plane, I first do what? Okay. That's all the questions. Put your clickers down. Yes, ma'am. Yes, I'll get it to you after this lesson. And then I will. Now what you're going to do, you're going to, you know who your partner is. With your partner, you need to listen carefully. With your partner, you're going to have to identify and locate some locations using an ordered pair. Everybody's getting one of these. This is just one quadrant of the big coordinate plane. Okay? These numbers, right here's the origin, because this is the location of what, Emily? Of 0, 0. This is your origin. Everybody's coordinate plane, or the quadrant that you're getting, looks the exact same. The x-axis go from 0 to 26. The y-axis go a little bit more, but we're just going to say that everybody's ordered pairs, you're going to use the numbers between 0 and 26. And you're going to create 5 ordered pairs. So in just a second, everybody's going to get one of these in a marker. And you're going to flip it over on the back. You're going to flip it over on the back, and on the back, you're going to make 5 ordered pairs. Remember, my numbers have to stay between 0 and 26. So somebody give me an example. One ordered pair that I could have would be what, Amelia? 115. If I had 115, it means what, Corey? What am I going to do first? Look at the one first, and this means what I'm going to do on what set of axes? I run, then I jump. So first I'm going to go along the x-axis. And then this number tells me what I'm going to do on what, Corey? The y-axis. So when you get this, the first thing you're going to do is you're going to come up with 5 ordered pairs using the numbers 0 through 26. That's the first thing you're going to do. And then after everybody has that done, I'm going to say, okay, you're going to work with your partner now. And if Luke and I are partners, I have 5 ordered pairs right here. You have to decide. I'll give mine to him first. So on his paper, he has a marker. I'm going to tell him, okay, my first ordered pair, Luke, is 115. So on Luke's coordinate plane, he has to locate 115. So he's going to go over 1 and up how many, Emma? 15 and make a mark. And then I'm going to give him my second ordered pair. It could be 226. Miss Brown said we had to stay between 0 and 26. Okay, it could be 226. Okay, look, now you're going to go 226. When he gets my 5 completed, I'm going to check. And we're going to self-assess each other, and I'm going to look and I'm going to say, okay, Luke, better think about that number 2. I think you got it backwards. I think you jumped before you ran. I think you went up 2 instead of over 2. When he gets my 5 done, and we've talked about it, he's going to flip his paper over, and I'm going to plot his 5. Who has questions?
So you're saying that we do not render our like 115. If we create that, we don't render it on the board.
On the front here?
Yeah.
Like, okay, Luke's my partner, and he has plotted the exact location of 115.
I'm saying we create, like, I have this paper, on the back I put 115, so I plotted it now.
No, you don't plot it. You're just writing yours on the back. And then, if Luke's your partner, then Luke's going to, after he's plotted all 5 of yours, you're flipping your paper over, he's flipping his to the back, he's going to read you his 5, you're marking his 5.
And I got it. How would us 3 do that? Like,
I'll come tell you in just a second when everybody's working. We'll work it out. Who else has a question on what you're doing? You're plotting your partner's points. They're plotting yours. But the very first thing you're doing when you get this is you're going to come up with 5 ordered pairs. You're not going to do anything further than that. If you have a marker in your desk, you can get it. Otherwise, Blake's bringing you one. Okay. Yes, it has to be dry erase. No, you're not moving yet. You're doing this part by yourself. I understand that. The y-axis go all the way up to 36. But Miss Brown said, just for less confusion, your x and your y is going to stay between 0 and 26. So right now, I should see everybody on the back of their coordinate plane. You have numbered it 1 to 5, and you're coming up with 5 ordered pairs between 0 and 26. You can, and y'all will just have, each of you will have 10 exact locations on yours instead of 5. Okay?
oh,
Each of y'all will have 10, because you're going to do the Austin just asked a good question. Austin says, Miss Brown, does the x-axis, right? Does the x-axis have to be greater than the y-axis?
no.
Austin, what was this?
0.
0 what? Was the x-axis greater? Does the x-axis have to be greater? Nope. As long as both numbers are between 0 and 26. When you're finished with your 5, you're just waiting. Okay. Oh, it has to be between 0 and... number's too big. These numbers are too big. Okay, I'm raising my hand because I still need a few minutes for these 5 ordered pairs. Anybody? Okay. A few seconds. Nope, you haven't started plotting yet. Okay, you're now going to, you already know your partner. You're going to get with your partner. Somebody's going to go first. I'm going to read my ordered pairs to my partner. They're going to find the exact location on their order on their coordinate plane. No, you're not right What's the order? 1, 2, 3, eyes on me. 1, 2, 3, eyes on you. It may help if your partner can see the ordered pair, because I just came over here and I overheard Tyler saying 29. That kind of makes me think the number 29. What Tyler means is 20, then 9. But it may help if Cutter can see that, so he means 20 and then 9. Go.
Can you connect them like all on, or just have the dot? That confuses me. The dot.
What?
Like, just putting the dots, or just connecting them.
You can connect them. But just the dots are fine, because all you're doing is plotting the exact location. No. Okay, my turn now. Okay, you're going to do me a favor since you're finished.
You done it? Okay. Okay.
1, 2, 3, eyes on me.
1, 2, back to you.
As I see you and your partner getting finished, I'm going to ask you to come out into the hall with me for a few minutes. And then as everybody in here is finishing, I'm going to give you more directions. But right now, as you're finishing, I'm going to have you come out. You're going to need to bring a pencil with you if I bring you outside.
Okay.
You're not talking. You can't talk.
11, 12.
You have to do this by yourself. So the first point you're looking for is
Here's my line.
okay. Up. Which one do you have to do first?
We've got to be respectful, please.
Where's the show me the x-axis and the y-axis on this coordinate plane.
Nice lined up, ladies.
Okay. And if you're looking at I, you had to go which way first? Okay. Which would be? Okay. And you're looking at I. Start at the origin. Look, start at the origin. Start at the origin. You're going over. Where? Let me see yours.
Yep.
Good job. Okay. Now look, you do not have the same points. Okay. So you're not out here talking about it. You're doing it by yourself. Oops, sorry. How are you?
What are we going to
If you're finished with your partner, raise your hand quietly for me. So, while you're waiting, put your top on your marker. Put your coordinate plane to the side. This is what you're doing in here until I call you out to the hall to plot those locations. When I call you out in the hall, Nathan, I'm going to give you a paper that looks like this. Your points out on the coordinate plane outside, I've plotted A through Z. So there are dots out there that are labeled A all the way through Z. You're going to get a piece of paper. Nobody has the same piece of paper. You have 6 points. You have to tell me the ordered pair. So, it's the opposite kind of what we did here. If this was the point B, okay, so on my paper, my first point is B. Okay, so I have to think in my head. The first way that I write an ordered pair or identify an ordered pair is by the what axis? X-axis. So B is located 5 over and 4 up. So if B was on my paper, I would know the ordered pair is 5, 4. Who has questions? Those are the points that you're located. If you are inside here, what you're going to be doing, it's called a coordinate picture. Because sometimes Brandon and Nathan and Kirsten were already asking to do it when they plotted their points with a partner. Miss Brown, can we connect these? And I said, you can. Because on a coordinate plane sometimes, one of the key words that you'll hear us talking about in this unit is called image. It's called an image. And an image, when you're talking about coordinate planes, is the picture or the image. Sometimes it may actually look like something. Sometimes it may be a shape. Sometimes it may be just a squiggly line, but either way, it's an image. It may not be a pretty picture of a flower or a pretty picture of a dinosaur, but guess what? Sometimes it can be. For morning work this week, Amelia, you'll probably find some of these and you're going to have to connect them, and it probably will create a pretty picture. But either way, even if it's not a pretty picture, it's an image. You create images when you find exact locations and connect the dots. So on this paper, as I'm calling you out in the hall, everybody